closed-like deformable objects exhibit a large variety of elastic properties, which affect their dynamics. These properties are often unknown a priori, but they could influence the manipulation strategy of the robot. In this work, we study the problem of learning dynamics of deformable objects that generalize to unknown elastic properties. We propose EDO-Net, a method that jointly trains an adaptation module and a forward module to learn dynamics of cloth-like deformable objects, represented as graphs. EDO-Net generalizes to unknown elastic properties by leveraging a latent representation Zi, learned in a self-supervised fashion. We obtain information about the elastic properties of the cloth by means of a pooling exploratory action. Given a sequence of observations collected from this action, the adaptation module extracts a latent representation Zi of the elastic properties of the cloth. The forward dynamics module then leverages the latent representation to predict future states of the deformable object. To evaluate the quality of such predictions, we consider two simulated environments, a lifting environment and a partial bandage environment. We also replicate the partial bandage environment in the real world. We present a comparison between the graph predictions of EDO-Net and a baseline knot condition on Zi, which we call NC. We can observe how EDO-Net successfully learns how to leverage Zi both in simulation and in the real world, which allows to obtain an accurate graph prediction to very elastic properties. For more details, don't hesitate to read our paper or contact us directly. Thank you.